Hello guys, welcome again and thank you for supporting. Today we are going to do something new. You can say today's data is something different from the others data what we have done previously. This is called load digit data. If I say about there are some digits and a size by 8 by 8 matrix and you can say in the digits there are some numbers mentioned 0 to 9, and on based of that digits you have to identify which numbers is what. Got it? Under this data we are going to cover all these 8 points which you are seeing. We will do the EDA of the data, we will do some visualization, we will cover eigenvalue and eigenvector analysis. We will do PCA, principles component analysis. This is a dimension reduction techniques. We will generate our model through decision tree and do prediction and accuracy. We will analyze the misclassification of the errors. We will use XGBoost to increase our model accuracy. And at last, we will do k-mean cluster. So let us start from our basic libraries which we need: pandas, numpy, matplotlib, and cbon. This is very basic, and I believe now you are enough to know that why we need all these libraries. I don't think we should repeat this session again. Once our libraries are stored, let import our dataset, and this time we have to import this dataset from the sklearn dataset, right? From sklearn datasets, I can import simply low digits, and I'm storing that data into a name of digits, right? If I want to see the keys of my data, I can see their data, target frame, features names, targets name, image, and description. At last, you will see DESCR. If I want to see my description of my data, let's print this also. So I can say simply something. It's not very detailed, but yeah, enough to know that their number of instances are 1797. It means 0, and number of attributes are 64. 8 by 8 matrix is 64, right? So this is some normal details about the dataset, and I always prefer to spend some time on the dataset and to understand the nature of the data before start any model or any prediction or any type of analysis you are going to do, right? Okay, now I want to show you my digits. So how this look like if I just want to show the number 0. So you can see this is looking something like 0. Okay, let me show you this in with the help of CMap. I am doing this PLT CM at gray, right? So which number you can see this in image, right? I can say this look like a 0, right? Can you also? Okay, let the my data frame and its head. I'm just storing my all the digits data and making a data frame now, and I'm giving the name to the data one. And once my data frame, because that's all the digit data, right? We have to give this digits data into a data frame, then only we can see it. Now my data frame is ready, and if I see the head of the data, so I can see the 5 lines of my data. It's a 64 lines and 1797 the rows. If I want to see the shape of my data and shape my image, so you can say my data shape is 1797 rows and 64 the columns. In my image shape is 1797 are the row wise and 8 by 8 is a image size. In my data set, if I want to see the first 5 lines, I can see how this look like. Of course, you cannot see it, right? But these are the numbers which help the computer actually to identify the that image and identify the numbers what is there actually, right? Don't see this like a 13 is a number, right? 15 is a number. No, no. These are the digits codes, which is not useful for you, but it's very useful for the any machine learning algorithm. If I see the target for my 0 to 5, it's a 0, 1, 2, 3, 4, 5, it's an index. And if I want to figure out my data, so let's see the figure size will be the 15 and 4. You can change this. And for the index, whatever I have given, I'm giving my label and I omit data digit 0 to 5, whatever we have selected, and target is my 0 to 5. Target is my index. And I'm just subplotting my index by +1 and IMSO IMSHOW. It's uh, a function actually in a matplotlib which we use to plot our and see our data set in the visualization forms. And I have given my reshape value 8 by 8 same, and I'm giving the color to gray so easily we can see. Block title will be the labels and the font size is 20. Once I run this code, so you can see on the 0 index, I can see actually 0, 1, 1, 2, 3, 4, 5, right? So the target of the digits, here we have given the target to our data set, right? I want to see the 0 anywhere, just come with the 0. I want to see the 1, I want to see the 2, I want to see the 3, I want to see the 4, right? So you can see anywhere, you can see 0, 1, 2, 3, 4. Got it? Okay. Suppose in the same data set, I want to see something which is placed on the index 1010. How can I see? Simply I will so implode whatever is so plt dot I am so digits image and I will give the index and I will give gray. You remember I have taken the gray number. If I remove this, this will show the colorful image. If I will put another R here, just type in, so this will show like this. All the blackout will be there, right? You can only see simply picture 5. Let me show you the same thing here also. If I just add another R, so you can see the same picture, but the background image of the black that will be removed completely, right? Okay, now I want to start my the model. Till here we have seen the visualization of the image, how each image look like, right? So you should have some idea what we are actually going to do now. Now I'm giving the defining my variable and independent variable x and y. So let's do this. And if I see the shape of my x and shape of the y, so I can see the shape of the x is a 179764, of course, and y will be the remainder one column only. Okay. If I just want to show the x, you will not get it, but again, this is something which your machine need, right? This is not your language, but your machine language, of course. And y of course, y will always be 0, 1, 2, 3, 4, 9, right? More than 9, there is no numbers. Okay, now we have to use the standard scalar, and I believe you know why we use this function. Yes, you are right, to normalize अपना data, because these are the image and these are not the normalized. So let's do our standard scalar now, and let's fix our x standard here, and let's transpose the same data. So we can easily check our data, how this look like. Now, if I want to see the covariance, so I believe you know all what is covariance. It provides that the measure of the strength of the correlation between two variables or more sets of the variable. If I want to covariance, and let's gray out this one. So I have run my covariance, and for the covariance prospects, if I want to see the minimum covariance, that is minus 0.570. Okay. Now let's move to eigenvalue and eigenvector. In NumPy, we can compute the eigenvalue and write the eigenvector of the given square array with the help of the NumPy. Of course, there's a function that's called linearlag.eig, and this will also help you to find out the value and the vector both. It will take a square array of the parameters and it will return two values. First is a eigenvalue of the array, and second is the eigenvector of the array. If you just want to understand the eigenvalue and eigenvector in a simple way, allow me some time, right? Let's just keep focus on this code only. If you see the eigenvalue, eigenvector, I've just given the NumPy code linear lag and with my covariance met. So this is done now. If I want to see my eigenvalue, so these are my eigenvalue of the each area of that image, right? 8 by 8 image. So 64, if you count this, this will come to 64 eigenvalues. And it represents the magnitude or the importance. Bigger the eigenvalue correlate with the more important data, right? If the eigenvalues are greater than 0, it's a good sign. So of course, the higher the value, good a sign, right? Now let's find out the eigenvector. So this is the eigenvector of the same image and the count will remain same 64, right? If I want to see the eigenvector total, so it's a 61.03 blah blah blah. Now I want to give you a brief idea. This is not eigenvalue eigenvector class, but still I want to cover this because topic is already open here. So let's focus on these two image only. In this image, you can see a red circle and a blue circle. So, simply you can see that red circle, which is on the same position, there is no change, and a blue circle is going to straight from the right side, right? So direction is getting changed for the blue one, right? So here we can see pink arrow is an eigenvector because it's a shape, there is no change, and blue one is an eigenvalue. Now, same you can correlate with this image data, low digit data. On every square, there is an image, and eigenvalue. What is how that is change going to left or right, and eigenvector is a downside of that square, right? I believe you got this. Is in easy way. Okay. Now I want to see the percentage of my eigenvalue, the total. Total we have already checked here. It's 61, and I want to see the percentage of the each value by the 61. And with a simple math formula, I'm not doing something. I'm taking the I value of the total divided by and multiply by the 100. It's a 12%, 9%. These all are the percentage value, right? If I want to see now the cumulative sum of this, so I believe you know cumulative, how to compute that. If no, let me this 12, 12 plus 9, 21, 21 plus 8, it's almost 29. So here you can see 12, 21, and 30, right? So we have to keep adding the next number, that is cumulative numbers. We have here, and this is a numpy function, np dot come sum, or the data source. Okay, now I want to show you the cumulative. We have taken the two things here, right? Cumulative explained variance and the explained variance. Now I want to show the pilot same things. These are the same value, guys, which we have taken here, right? This is the variable expenditure, that is the percentage of the total, and this is the cumulative of that balance. So here you can see this blue line is a cumulative balance, how it's going to I, and this is the individual explained variance, right? Now let ready our data set for the model generating, and for that always we have to train and test. From sklearn model selection, you have to import the train, test, and split, and give the data set extend x y train, and with the train size of 80%. Now let do, if I just want to see, okay, I have to import that first. Okay, so I can see the train size is 1437 and 64. You can see the shape of the everything, right? Test y train and y test. Just for example, I want to show this. The test shape is 360 by 64. Now we are applying PCA, right? And PCA is a dimension reduction techniques. Now you will see my dimension is here 64. And once I will apply PCA, I have to import that from decompositions, and I have to give the n components to 20. Means till 20 I want to reduce this. Now my dimension is 64 and I want my model to reduce it by 20. Why I am reducing this from 64 to 20? This is very detailed study. You have to go to my next video where I have explained very well why PCA is required and how much is required. There are two terms, PCA and LDA, right? So PCA is unsupervised learning, and I don't want to cover this here. This will take so much time. So just for now, try to understand. I'm just reducing my data from 64 to 20. Let's fit my model, and now let's see the shape of my data now. Earlier test shape was the 360 by 64. Now you can see 360 by 20. So you can see this, you can tell this actually the remaining 44 columns we don't need. 20 columns are enough to give us same information what other 44 was giving. In a simple language or other way you can see this like, right? That's why we do PCA. And this is good to reduce the size, time, money and extra space. Okay. So after PCA, I want to generate a model. So I have selected today decision tree. You can do anything. So you can apply random forest also here, right? This is all your wish. I have selected decision tree, and for applying decision tree, I have to import it from the tree decision tree classifier, and in the classifier I have to fix my PCA extend now, right? PCA extend. This is my new data set. New data set after applying PCA, right? Remember this. Y10 will remain same. And now I have to set prediction also. So these are the prediction based on the decision tree. I'm not sure how much these are correct. So we have to check this. Now let uh, import figure size to all three. And I want to show you actually how decision tree can be plotted. This will look like something you can say a big mountain types, but this is very important too. You should know how to plot a decision tree. It's a very victory, so this is taking time, and it will show you all the algorithm. So you can see my data is still running here. Right. Surprise? Wow. How yummy it look. You got something? Believe me. This will take so much time to explain you, but for now this is look yummy, and you can see how your decision tree is look like here, right? Perfect. Now let's move to the accuracy check, and of course we need some libraries. So let import the accuracy score confusion matrix from the sklearn matrix and to prediction. And guys, remember we are doing prediction, and prediction is against by test, right? So this is my confusion matrix, and of course, this is also technical. In a easy way, we can check our accuracy. Accuracy is 80% now, right? I will not say it's a good or bad, but 80% is not satisfying. Let's do something, right? Okay, let's do something. I want to improve my accuracy now. Okay, and for that, I already told you we will do XG boost. Remember? Okay, before that, we have to cover the misclassification now. Okay, if suppose I want to know how much predicted value have the 7, right? That equal to 7. 41. Simple numpy formula, right? With a simple numpy formula, you can see any value. If I want to see the predicted value is a 8, that look like a 8. So as per the prediction, 33 models, the 33 columns means the image 8 by 8 look like a 8. Okay. Now let's see misclassification size. What is misclassification actually? That means images are misclassified. It's a percentage of the observation are incorrectly predicted by the model. Okay, how will do that? I have to define the misclassifications, and I will do this with the y prediction and by test. I will create a list of misclassification help to the index value, and I will apply for the index in the predicted value and the actual value, and I will do the emulate for the by prediction and by test. If prediction is not equal to actual, right? If my by prediction data is not equal to by test data, then append this to misclassification list which we have generated here. This is blank now. Otherwise, return to misclassification. Now let's see what happened. So my everything comes to misclassification, right? And now get misclassified by index between predicted value and by test value. Now let's see. Okay, we have to run this first. Oh, wow. I can see many values are here index wise which were misclassified. Oh, if I want to count this, how many? 70 value approx are misclassified. Okay, I want to plot this actually. Let me try to plot this. Okay, so just an example, right? You can check your also. I'm just doing for the five. So you can see the predicted versus actual. Prediction by 0, actual is 9. Wow. Predicted is 7, actual is 4. Prediction is 3, actual is 9. Prediction is 9, actual is 3. Prediction is 0, actual is 6. So sometimes, right, system is also not able to understand the some image, how this is look like. So that's why there are chances always misclassifications. Okay. Now remember our accuracy was previously after PCA we have done the decision tree and got the accuracy of 80 percentage. So now we are going to improve our accuracy by applying SG boost. Let's install this. I should have this already. Okay, this is running now. Okay, it's already in there in my system. Now let import the XG classifier from the XG boost, and I'm generating a model where I will fit my PCA train data by the by train data. Okay, it's fitted now, and now I'm giving my by prediction model, applying that with the PCA data and prediction based on the round of the y direction. Wow, this is done. And if I check about the accuracy now, wow. So you can see, guys, earlier this was 80 percentage when I did this. Let's go to back, right? This was 80 percentage when we applied the PC and this decision tree. But after XG boost, this is almost 90 percentage, 93 percentage. It's almost 94 percentage actually. So this is good. Almost 14 percentage we have increased our accuracy. That's why we always use this type of uh, performance gear, right? If I want to accuracy, this is 93.61 percentage. So this is a great model. Okay, that's just small things I want to do this. I just want to k means here in the prediction. This is not necessary, but still I want to show you how to do that k means in the PCA. I just import the k means and just do the cluster I want to issue and random state by t, and I'm just applying this on the PCA data. Okay, this is done. If I want to see the shape of my k means, I can say simply there are two clusters with the value of the 20, right? If I want to say this, these are the clusters value which I can tell. from this data. So I believe I tried to cover everything in my board. And at last, I just want to say you thank you. Thank you so much for your support. Keep watching. Thank you.